Okay, in this screencast, I want to go through the vector equation of a line. So what is how do we represent a vector as an equation using vectors? And before we do that, I just want to take you back to an old friend, except I'm going to present him as y equals not mx plus b, but b plus mx. Because our understanding of this, which is fantastic, and thorough, our understanding of this situation here, I know it is, because you've dealt with this guy a lot. So this is the equation of a straight line with only we only need two bits of information, don't we, to establish the equation, the unique equation of a line, and that is, in this case, b representing the y-intercept, or a known point. Okay, so y-intercept here, which is a known point, and m in this format looks like, what does m represent? Well, it represents the gradient or the direction of the line, and it works the same for vectors. For a straight line, we just need the gradient or direction and a point. For a vector, which comes in this form, r equals a plus tb, it's exactly the same. Our a represents a position vector, so a known point, or a known point, a known position that the vector goes through, and b represents our direction vector. So what direction is our vector going in? Direction vector. You can see no different to y equals b plus mx. Known point, gradient or direction, known vector, direction of the vector. So this is our vector equation of the line right here, and that's what we're going to be talking about in this lesson. Okay, so all we're going to need to do is take our information and determine a point that the vector lies on, and the direction that it goes in. That's all, and then we sub them in, and we're done. So it's very similar to a question that we might have got for y equals mx plus b. If we know what the y-intercept is, if we were told that the y-intercept is equal to 2 and the gradient is equal to 3, then we just go, well, that's easy. That's y equals 3x plus 2. Or it might have been a bit harder. It might have said, oh, look, it goes through 1, 2, and minus 3, 0. And you had to work out, oh, well, I better work out the gradient. In which case, my gradient here is 2 minus 0, 2 over 1 minus 3, so 2 over 4, which is a half. All right, so my gradient's a half, and it goes through, or it might go through, I haven't got my y-intercept here, but I can just sub in a point and I can get it kind of, so I know it's y equals 1/2 x plus some unknown b we're not sure about yet, but if I put in minus 3, 0, right, I get minus 3 over 2 plus b, so b must be equal to 3 over 2, and so my equation is y is a half x minus or plus 3 over 2, the equation of the line. We're going to be working with very, very similar bits of information to find out what the vector, what our vector equation is. So let's look at an example now. So my example here, so forgive my rushed notes here, because all I was doing in this section, you didn't need to be taught this. I was just bringing it back to the surface so that we can tap into what's required here for the vector equation of a line. So for the first example, I'm just taking it out of the book, find the vector equation of the line through, I'll just pause. So here's a question, find the vector equation of the line through this point parallel to this vector. You'd have seen similar questions with y equals mx plus b, where you're given a point and told that the line is parallel to another line, and you extract from that other line the gradient, you sub that in for m, and then you use your y equals mx plus b or the whatever to get the equation of the line. No different here. So what we're going to find the vector equation of the line through this point. All right, so what do we start with? We don't start with y equals mx plus b, we start with r equals a plus tb. Okay, so r and t are going to hold, a and b we're going to find out. Now a straight away is just a known point, it's position vector, 1 minus 1, 3, so we can put that in straight away. So this value here is, well, we can write that in vector form as I minus j plus 3k, right? That goes in for my known vector. Now what's my direction vector? Well, it's parallel to this one, so it's going to be minus minus 1, 3, minus 1. That's my direction vector. So I can write this equation, therefore R equals, now I've sort of mixed them up here in terms of my notation, haven't I? This is in unit vector form, this is just in point form or vector form. So what I should do is be consistent, and this will be written just exactly as it is there. So it'll be R is equal to I minus J plus 3K plus T minus I plus 3J minus K. So that's the vector equation of the line. I could have written it as, right, or R equals, and now I could give myself a bit more room, R equals, I could say that this is 1 minus 1, 3 plus T minus 1, 3 minus 1. So you can see here that's my position vector, 1 minus 1, 3. And my direction vector in here is just the same direction as the vector minus I plus 3j minus k, so minus 1, 3, minus 1. That's my direction vector. And this is my position vector. Okay, so there's the equation of that line. Part B of this example. So part B, find the vector equation of the line through these 2 points. Okay, you've seen this sort of question before, but not in vector format, but it's the same idea. What do we need to do? We need to work out what the direction vector is. So we need to work out what AB is. All right, so AB is equal to, it doesn't matter whether we go AB or BA, it's the same direction. So it wouldn't matter if we went in the BA direction, the vector equation of the line would still be the same because it goes through these points A and B, the vector equation of the line that goes through these points. It doesn't tell us which direction it's going in, so it's just going through 2 points. So I'm going to go with AB, which means that I am going, my direction vector is from 1 to minus 2, so I'm going minus 3. So if you like, minus 2 minus 1, 1 minus 0, and 1 minus minus 4. So that's my direction vector. So we just need to work out, that's my direction vector. Okay, now my position vector can be either A or B. It doesn't matter which one I use. So therefore, R is equal to, I'll go with A, that's my fixed point, 1, 0, minus 4, plus T, minus 3, 1, 5. And we are done. So that's the vector equation of the line through those 2 points. Just one more part to this, and then we'll finish the screencast. So the last part is just to draw in from the last section that we're working on, find the acute angles between these 2 lines. So we're gonna access cos theta is equal to A dot B over AB. Got 2 lines here now. We have line 1 here and line 2 here. Okay, so what's A dot B? Well, these are the 2 vector equations. So A and B refer to the directions that the vectors are going in. So we're concerned with the direction vectors. So we're concerned with direction vector 1, direction vector 2, and we're going to use those. So A dot B will be equal to, and I'm just struggling because I'm going backwards and forwards, but we're looking at A dot B being minus 3 times minus 1, so that's 3 plus 3, 6, minus 5, 1. So A dot B is equal to 1. My magnitude of A is 1, 9, 1, so that's square root 11, times 9, 1, 25, square root 35. So cos theta is equal to 1 over root 11 times root 35. Put that through the inverse cos, and I think we'll get 87.1 degrees to 3 significant figures. Okay, that's all we need for exercise 12J now. On page 432, a couple of pages of questions there. We'll trim that when I see you in class on Monday. And then there's just 2 more sections after that. and we're done. We're done with the SL course, and then plenty of time to get on with exam preparation. Okay, I'll see you soon.